Morning, grade 7. We're moving on today to the surface area of pyramids. I just want to point out to you that you'll notice for a lot of this unit, we're not going to be using the textbook in terms of the questions. So when I say that we're doing lesson 13.3, that means there's still really helpful information for you to look at in the textbook, but we're probably not going to be doing questions from there. I find that a lot of the questions in the textbook are application questions, and I don't think we're quite ready with that for that. So I'm sticking to a little bit of easier questions on worksheets where we really get the basics down so you're ready for grade 8 when you get to 3D shapes, instead of trying to go too quickly and then do all the application questions. So today we're talking about the surface area of pyramids, which is going to be actually pretty similar to yesterday's lesson on the surface area of prisms. So here I have a triangular pyramid. Remember that a pyramid, the point of a pyramid, or the way it's different from a prism, is that all the different faces come together at the top to make a point. That's how a pyramid is different than a prism. So whenever you're trying to find the surface area of any object, the most important thing is to figure out how many faces there are. So in this case, I'm working with a triangular pyramid. So if I wanted to, I could draw a triangle as my base, which is kind of what I have right here. It's my base. Then it might be helpful for me to draw a net and think to myself, okay, if this is my base, how many different triangles are coming together to form the top of my pyramid? 3 more, okay? So in total, I have 4 faces of my pyramid. So whenever you're finding surface area, make sure that you're thinking about how many faces are there when you try to calculate the total surface area, because you'll need the area for each of the faces. Then the other thing I wanted to point out to you was the difference between the height and the slant height of a pyramid. Now, in this case, the height is not something we're really going to be using today, but I wanted to show it to you. So the height is as if we were in the very center of the actual shape, very middle inside the shape, and went all the way up to the top of the pyramid. That's the actual height of the pyramid. So if someone said, well, how tall is this pyramid? That's how you would measure it. But what we're going to be working with today is the slant height. And that is really, if we look over here at this triangle, that's the actual height of one of my triangles going up the side. And that's going to be helpful for me to calculate the area of my triangle. So just be aware when you're solving problems to think about, do I need the height or the slant height? In this case, we're using the slant height in order to figure out the area of the triangle. So here I thought this was a little bit easier to see because it had all different colors. But we have the slant height is highlighted for us here. It's 10 millimeters. And then you have the length of each side of your base. Okay, so then we have a net. So this is a rectangular pyramid or a square base pyramid. So again, you'll notice that there are 5 faces. And then what the person did here was they first found the area of the square, which is the base times the height, 8 times 8. And then they found the area of each of these triangles. And they did the base times the height, which is our slant height, 8 times 10, and then they divided by 2. And then you could add those all up together. So I just wanted to show you this one as an example very briefly because I thought it was helpful for you to see the net as to where the square base pyramid comes from. So let's try 2 examples together going through each of the steps. So here I have a triangle. Again, what I want you to see is that I have the actual height, which is 15 inches, and then I have the slant height, which is what I want to use. For right now, I don't really care about the real height of the pyramid. So maybe it's helpful for me to draw myself a little net so I can think about what I'm folding up in order to calculate the surface area. What I want you to do on your worksheet is if it only gives you one measurement for the base, assume that these are all the same. And no, it's not quite drawn that way, but it's really difficult to draw it to scale. So because we see 16 inches here, we're going to just assume it's 16 here, 16 back here, and then 16 on this side. So let's say I want to find the area of area 1. I would do base times height because it's just a square. Area 1 is base times height, which is 16 times 16. Area 1 equals, and like I said on my other video, feel free to use your calculator for these problems. So my area is 256 inches squared. Now let's find the area of area 2, which is going to be one of my triangles going up. So because it's a triangle, I know that my formula is base times height divided by 2. Then I get the base times the height. Well, my base is 16, and now remember, this is why I taught you about the slant height. I want to use the slant height because that slant height is the real height of the triangle I'm working with, not the pyramid. The pyramid height is this inside one, the 15 inches. So I'm going to do 16 times 17 divided by 2. And then I get that area 2 is 16 times 17, and then I divide by 2 is 136. Now, the handy thing about finding area 2 is that it's actually the same as 3, 4, and 5. So what I could do, I'm running out of room here, is I could multiply area 2 by 4 because there's actually 4 area 2s if I wanted to, because all of these triangles are the same. So I could really do 136 times 4, or I could add 136 4 times, and I get 544. And then my final step, so the 544 represents all the triangles, and now I'm going to add the 256 from my inner square, and I get 800, running out of room, inches squared. So really, grade 7, in order for you to complete a problem like this, you need to know how to find the area of a square, how to find the area of a triangle, and then you need to know, well, how many triangles am I actually using? All right, let's try another one. So this one, fortunately, has told us automatically, here's my base, it's 5 centimeters, and then we have these little notches that show me it's 5 centimeters all around. Then this one only gives me my slant height, which is fine, because that's really all I need, which is 8 centimeters. So again, let's do the area of my square first, which is 5 times 5. Area equals 25 centimeters squared. So I just did that. We'll call it area 1. Then we'll do this triangle here. We'll call it area 2. Or even if you wanted to, you could call it area triangle. Base times height divided by 2. Sorry if my pen's a little bit clicky. Base times height, so I get 5 times 8. I divide by 2. And then my area 2, I get 5 times 8, and then I divide by 2, is 20 centimeters squared. Now again, remember that I have now found the area of just this triangle right up here. But there are actually 3 more like it. So if I wanted to, I could just add them. Oops. Let's try that again. I'm going to do a little bit smaller. So I could add triangle 1, triangle 2, triangle 3, triangle 4. I've got 4 triangles. And then I have my square. So then I get 2, 4, 6, 8, 10. I get 105 centimeters squared. Okay, so when you do your work, just take it one step at a time. Make sure you found the area for all of the faces and then add it together. Feel free to chat with me if you have any questions. I hope you have a great day.